Okay, students, we're going to look at a few examples of the mid-segment theorem itself. Okay, up here it states that I've talked about in the quarter law hierarchy already, so now I'm just going to show you some examples. These are going to be with triangles. Now in the quarter law hierarchy, we had two bases. For example, it's a trapezoid. You have a base up here and then connect down here for the second base here. So in the triangle, we can just think we have this base, which is really zero. There's no length here, so you can think of base 1 is 0 and base 2 is this. So when I say the sum of the bases for a triangle, it's going to be 0 plus this, so it's really only half of the base itself. Okay, so there's two characteristics of the mid-segment. Mid-segment, again, that would mean that this is equal to this. We take the midpoint, so T is the midpoint of RY, and E is the midpoint of RW. So these two are equal. So we connect the two midpoints, and that becomes the mid-segment. The two characteristics, again, off to the right here, this mid-segment is going to be parallel to the base, or base is if it's a quadrilateral, because you'd have another base up here if it's a quadrilateral. And this equals half of the sum of the two bases, this 0 plus this base. So in a triangle, it's really only half of this base. Okay, it's right here. When it's quadrilateral, you'd have two bases, add them together, divide by 2. But as I pointed out in the quadrilateral hierarchy, it's much easier to go ahead and just double this mid-segment and equaling it to the sum of the two bases. This base plus 0, or in a quadrilateral, you'd have this base plus the length of the top base. Okay, so I've thrown this example with variables because down here we have it just with numbers. Okay, even more simple. All right, so we'll do one of these as well. Now, since these two segments are parallel, we know parallel lines cut by a transversal corresponding angles are equal. So if that's 45 there, it's also congruent there. So this angle RTE has to be 45 degrees, as you then see right here. Whatever this angle is, say this is 50 degrees, then this is 50 degrees, this corresponding angle. Okay, and of course angle R has both angles, has this angle, it's the overlapping triangle. We have a small triangle here and a bigger overlapping triangle here. This angle R goes for both the small triangle and the big triangle. Okay, and then if you're trying to prove, talking about similarity, this would be reflexive property, angle R equaling angle R. Remember, most of the time in reflexive property, we talk about two segments sharing the same side, and then there's reflexive property, but it can also be overlapping triangles where the angle is being used in two triangles. So angle R could be used in the small one and the big one. So angle R equaling angle R, it would be a reflexive property also, if you're talking about a proof, just so you know that. Okay. All right, so let's go ahead. We'll come back to this one last because it's got variables in it. We'll just do these simpler ones first. Let's find the measure of angle FDV. Well, we just talked about. We have parallel lines cut by a transversal. Therefore, corresponding angles are equal. So it has to be 34. Very simple. Okay, we're already talking about corresponding lines. Okay, over here, given BC is 12. Well, we know BC is the, well, it's going to tell us down here. C, B, and V are the midpoints. So therefore, this is a mid-segment. So that means NM, this whole length has to be double that, 24. Okay, so I'll put the 24 right here, showing us the entire length. Put it underneath the V. If I put it over here, you might think this is 24. If I put it over here, you might think VM is 24. So you put it right underneath the middle. So that means the whole length is 24. It says CV is 20. CV, this piece right here is 20. Well, don't forget, since this is a midpoint as well, and this is a midpoint, this is parallel to this base. And so this is the mid segment. So double that, and you get 40. And this is VB. VB is 32. So that right there is 32. And again, that's the parallel side to XM. So this is the mid segment. So I double that to get 64. And again, put it right in the middle there. represents the whole length, 64. Now it says find the perimeter of triangle XMN. XMN. So now I know these three lengths, I can add them up. This actually has been on the park or the DCAS, this exact type of problem. Okay, I just give you different numbers, so make sure you know this. Okay, so 64 plus 40 is 104, 124, 128 is my perimeter. And then it'll give me units, so I'll just use the word U for units. If it was centimeters, it'd be centimeters, meters, meters, etc. All right, number 3. Again, they're showing me that these are midpoints H and K, so this is a mid segment. Angle J is 25, so I go ahead and fill it in there. And therefore, I would also know that this angle right here, its corresponding angle would be 25. Okay, for that angle. Find the measure of KHI. Oh, we just did it right there. Very simple. Find MN. Well, MN is the midsegment because we have these two being equal, these two being equal. So those are two midpoints connected. So that's the midsegment, which is half of the base. So half of 11 is 5.5. Real simple. Okay. Find GS. Again, it's the same thing. This is the midsegment. We can tell from here and here. So half of 18 is 9. Real easy. See how easy it is when you're just dealing with numbers. It's a little more work when you come back up here with the variable. Okay, last one. Find the measure of KGH. Again, corresponding angles, because the midsegment is always parallel to the base, and therefore we have parallel lines cut by transversal. Corresponding angles are congruent. Okay, and so now let's go back up here where you have variables involved. Like I said, this equals half of this. Well, I take half of this, I get 5x minus 10.5. I don't want to deal with fractions or ever have to deal with it. So it's easier just to double this mid-segment and equaling it to this. So I have then 4x equals 10x minus 21 and solve that. Add the 21 across. I don't always take the smaller variable over to the bigger side, so I get a positive answer. So 10 minus 4 is 6x. I'm going to divide each by 6, and 21 divided by 6 is 3.5. Okay, so x is 3.5 for this answer. We just said solve for x. Just to solve for the mid-segment length, then I go 2 times 3.5, and it'd be 7. And that would have to be 14, because it's got to be double it. Which is what you get. You get 3.5 times 10 is 35, minus 21 is 14. Okay, so there's that quick lesson on mid segments. Like I said, these are all with triangles, but even if it's quadrilateral, you just add that base plus that base and set equal to double the mid segment, as we did here, and then you'd solve it.